High above Earth, an experiment began that seemed routine, almost harmless. Scientists believed they understood every risk, every variable, every possible outcome. But space has always been a place where certainty slowly breaks apart. This mission was designed to test limits, yet no one expected those limits to push back. At first, everything followed the plan. Data streamed in exactly as predicted, systems responded with perfect precision, and the environment remained stable. It looked like another success in the long history of human experimentation in orbit. But beneath that calm surface, something subtle was already shifting. And the truth is, what we expect in space is often shaped by what works on Earth. Controlled conditions, predictable reactions, clear boundaries. But orbit is different. It is a place where invisible forces dominate, where small miscalculations can grow silently, unnoticed, until they are impossible to stop. And that is exactly what made this experiment dangerous. Not because it started with obvious risk, but because it didn't. It appeared safe, manageable, even simple. That illusion of control became its greatest threat, because by the time anyone realized something was wrong, the experiment had already crossed a line no one knew existed. And what happened next would force scientists to question not just this mission, but the very limits of human control in space. When the experiment continued, the first signs of instability were almost impossible to notice. Everything still looked normal from the outside, and the data remained mostly consistent with expectations. But deep within the system, small variations had begun to appear. At first, these changes were dismissed as minor fluctuations, the kind that often happens in complex environments. Yet space does not forgive assumptions, and what seemed insignificant on Earth can quickly evolve into something far more serious in orbit. The equipment started responding in ways that could not be fully explained. Measurements drifted slightly, timing became inconsistent, and patterns that once felt predictable began to shift. It was not failure, not yet, but it was enough to raise quiet concern. Astronauts monitored the situation carefully, relying on their training and experience. They had seen anomalies before, and most of the time those issues resolved themselves. But this time felt different. There was no clear cause, no simple explanation, and no immediate solution. This is where expectation and reality began to separate. On paper, the experiment was controlled. In reality, control was slowly slipping away. Each adjustment made to correct the issue seemed to create new uncertainties, as if the system was reacting in ways no one had predicted. The deeper they looked, the less sense it made. Data conflicted with earlier readings, models failed to match observations, and confidence began to erode. In space, distance amplifies every problem, and with Earth far below, there was no immediate backup, no quick intervention. And then a realization started to form. This was not just a technical issue. It was something more, something that challenged the very assumptions the experiment was built on. Because in orbit, even the smallest instability can grow without warning, and once it begins, stopping it may no longer be possible. That was the moment when concern turned into urgency, and the experiment moved one step closer to becoming truly dangerous. What made the situation worse was the growing realization that time was not on their side. Every second allowed the anomaly to develop, increasing the risk of a chain reaction that could spiral beyond control. The systems were interconnected, right? Meaning a single failure could trigger multiple consequences at once, amplifying the danger in ways no one could fully calculate. And in that fragile moment, the illusion of safety finally began to collapse completely, leaving only uncertainty and the moment. Everything changed began without warning. For a brief second, the system held together as if nothing had gone wrong. But then the instability reached a point where it could no longer be contained. Like data streams broke into patterns no one could recognize, and the response systems started reacting faster than human. Decisions could follow. What was designed to be controlled had become something unpredictable, almost alive in its behavior. Astronauts moved quickly, trying to stabilize the experiment before it escalated further. Procedures were followed, commands were issued, but nothing restored the balance they had lost. Every attempt seemed to push the system further, away from stability. This was the breaking point, the moment where expectation collapsed completely. On Earth, such a situation could be isolated, studied, controlled. But in orbit, there is no margin for delay. The danger was no longer theoretical. It was immediate, growing, and impossible to ignore. In that instant, the experiment revealed its true nature, not as a test of science, but as a test of human limits. And yet, even in that chaos, something important became clear. The same curiosity that pushed humanity into space was also what allowed them to face the unknown. Eventually, the system was forced into shutdown, ending the experiment before it could spiral into complete disaster. But the impact did not end there. What happened in that moment changed how scientists approached risk in space forever. It exposed the fragile line between control and chaos and reminded everyone that the universe does not follow human expectations. Right? From that day forward, every experiment carried a deeper awareness of uncertainty. Because for the first time, they understood that danger in orbit does not always come from what you can see, but from what you never expected. It changes everything forever.